Good morning, students. Welcome to 10th Science, Unit 11, Carbon and its Compounds, Part 2. Now let us recall what we learnt in the previous class. Introduction to organic compounds, general categories of organic compounds, classification of organic compounds based on the pattern of carbon chain, classes of organic compounds based on the kind of atoms, that is alkane, alkene, alkynes, characteristics of hydrocarbons, tests to identify saturated and unsaturated compounds by using bromine water. The color of bromine is purple in color. The saturated compounds, it do not decolorize bromine water, and the unsaturated compounds, it will decolorize bromine water. Now, the classification of organic compounds based on the functional groups. A functional group is an atom or a group of atoms in a molecule which gives its characteristics chemical properties. For example, alcohol OH, aldehyde CHO, carboxylic acid COOH, ether O. So a functional group is an atom or a group of atoms in a molecule. It gives the characteristics chemical properties. For example, ethane. The formula of ethane is C2H6 or CH3 bond CH3. So, any one of the carbon is replaced and the functional group is attached here. So, the functional group is alcohol. OH is the alcohol. So, the name is ethyl alcohol or ethanol. CH3, CH2, OH. This is ethyl alcohol or ethanol. In methane, CH4, you have to replace one hydrogen and the functional group is attached, means that is methyl alcohol. In propane, one hydrogen is replaced and the functional group OH is attached, means that is propyl alcohol. So, methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol. So, the series of compounds containing the same functional group is called as a class of organic compounds. Classes of organic compounds based on functional group. Classes of organic compounds, the functional group, common formula or general formula, then examples. The first one, alcohols. The functional group is OH. The general formula, that is ROH. This R refers to alkyl. What do you mean by alkyl? Means methyl or ethyl or butyl or propyl. So, R refers to the alkyl group. So, the general formula of alcohol is ROH. Example, ethyl alcohol or ethanol. CH3, CH2OH or C2H5OH. Ethyl alcohol, the common name is ethyl alcohol. The IUPAC name is ethanol. Second one, aldehyde. The functional group is CHO or C bond H, double bond O. Here a bond is there. The valency of carbon is 4. Here the general formula or common formula is RCHO. R refers to the alkyl group. Here this is acetaldehyde. CH3CHO. Another name is ethanol. Then the third one, ketones. CO or C bond O. Here bond is there. The alkyl group is attached. So the common formula is RCOR. This R and R refers to the alkyl group. So acetone, the example is acetone, CH3COCH3. The another name, the IUPAC name is the propanone. Another name is propanone. The fourth one, carboxylic acids, COOH or C double bond O, bond OH, a bond is here, here the alkyl group is attached. So the common formula is RCOOH. This R refers to the alkyl group. Acetic acid, CH3COOH. The IUPAC name is ethanoic acid. The fourth one, ester, COO or C double bond O, single bond O. Here the bond, here the alkyl group is attached. Or COOR. This R refers to the alkyl group. Methyl acetate, CH3COOCH3, methyl acetate. Ether, the functional group is O and the general formula or the common formula is ROR. R and R is refers to the alkyl group. That is, example is dimethyl ether, CH3O CH3, dimethyl ether, ether O. So these are the classes of organic compounds based on the functional group. Now come to the next topic, that is homologous series. What is homologous series? Homologous series is a group or a class of organic compounds having same general formula and similar chemical properties in which the successive member differ by a CH2 group. CH2 means methylene. For example, methane. The formula of methane is CH4, ethane, C2H6, propane, C3H8, butane, C4H10, pentane, C5H12. Here, you compare the first two, the common difference, the successive member, the common difference is CH2. Here, CH2. You compare the next one. Here, the successive member, they differ by a CH2. So, here, for example, this is propane, C3H8. The preceding member or the succeeding member, they differ by a CH2 group. That is a methylene group. So, what is homologous series? Homologous series is a class of organic compounds having same general formula. The same general formula is CnH2n plus 2. And they have the similar chemical properties in which the successive member differ by a CH2 group. So let us consider the member of alkane. Methane, the formula is CH4, ethane, CH3 or C2H6. Propane, CH2 or C3H8. Butane, CH2 or C4H10. Pentane, CH3 or C5H12. So this general formula is CnH2n plus 2. Then what are the characteristics of homologous series? The first one, each member of the series differ from the preceding or succeeding member by one methylene group. Methylene group means CH2. And hence by a molecular mass of 14 atomic mass unit. So here in methylene the atomic mass of carbon is 12. Hydrogen 1 into 2, 2. So 12 plus 2, 14. So the molecular mass, they differ by a 14 atomic mass unit. The second point, all members of the homologous series contain the same elements. For example, methane, ethane, propane, they contain the same elements, carbon and hydrogen, and same functional group. So functional group means alcohol, OH. If it is attached with OH, the functional group is OH, means it contains carbon, hydrogen and oxygen. So all members of the homologous series contains same elements and same functional group. They are represented by a general molecular formula that is alkane. Alkane means it contains a single bond. The general formula is CnH2n plus 2. The fourth point, the members in each homologous series show a regular changes or gradation in their physical properties with respect to their increase in molecular mass. So, the successive member, the molecular mass increases. That is a 14 atomic mass unit. So, the physical properties also changes. The chemical properties of the members of homologous series are similar or same. Then all members of this series can be prepared by a common method or same method. So, these are the characteristics of homologous series. Now, we pass on to the next topic, nomenclature of organic compounds. Now, why do we need the nomenclature? In ancient days, the names of the organic compound were related to the natural things. For example, formic acid. Formic acid was distilled by the distillation of a red ants. So, here the Latin name of red ant is formica. Here, later on, the scientists synthesized the number of organic compounds by a set of rules was formulated by a IUPAC rules. The expansion of IUPAC is International Union of Pure and Applied Chemistry. Now, what are the components of an IUPAC name? The IUPAC name of any of the organic compound consists of three parts: root word, prefix, suffix. These parts are combined as per the following sequence to get the IUPAC name of the compound. Here, prefix plus root word plus suffix, they combine to give the IUPAC name of the compound. The first one, root word of hydrocarbons. What is a root word? Root word is a basic unit. It describes the carbon skeleton, the number of carbon atoms present in the carbon chain. The parent chain of hydrocarbons containing the 1 to 10 carbon atoms. So, the number of carbon atom, here the number of carbon atom is 1, the root word is meth. If it is 2, it is eth. It is 3 means the root word is prop. The number of carbon atom is 4 means the root word is but. If it is 5, the root word is pent. If it is 6 means the root word is hex. If it is 7 means the root word is hept. If it is 8 means the root word is oct. If it is 9, the carbon atom is 9 means the root word is non. And the number of carbon atom is 10 means it is death. These are the root words of hydrocarbons from 1 to 10 carbon atoms. Then the next one, prefix for IUPAC name. Prefix. The prefix represents the substituent or branch of the parent carbon chain. Here, the substituent is an atom, F, Cl, Br, or group of atoms that is other than hydrogen. They attach to the branch chain, so they are called as substituents. For example, F means the prefix word is fluoro, Cl means chloro, Br means bromo, I means iodo, NH2 means amino, CH3 means methyl, CH2CH3 that is ethyl. So these are the substituent. You have to use the prefix words. Now we pass on to the suffix for IUPAC name. The suffix, they forms at the end of IUPAC name. It is divided into two parts such as the primary suffix and the secondary suffix. The primary suffix means here the carbon atom is attached with the other carbon atom. They attach with the single bond. All the carbon bonds are connected with the single bond, and the suffix is completed with the ANE. if it contains double bond ENE, if it contains triple bond YNE. What do you mean by secondary suffix? Secondary suffix refers to the functional group. For example, a class of compound alcohol. The functional group is OH and the suffix used is OL. And the aldehyde is CHO. The suffix used is AL. Ketone, CO. The functional group is CO. And here it is completed, the suffix used is 1. That is, for example, propanone. Carboxylic acid, COOH. The functional group is COOH. The suffix used is oic acid. For example, if it contains 3 carbon atoms, is propanoic acid. So these are the suffix used. That is, alcohol means OL. Aldehyde means it completed, the suffix used is AL. Ketone means 1. And carboxylic acid means oic acid. So these are the components of IUPAC name, that is prefix, root word and the suffix. You can get the IUPAC name. Now, what are the rules? IUPAC rules for naming the organic compounds. For example, now look at the formula. CH3, CH2, CH2 bond OH. Now, you count the carbon atoms. How many carbon atoms? 1, 2, 3. So why here put here 1 means here the functional group is attached with the carbon atom. So on the left side or right side you have to number the carbon atom, but the functional group is attached with the lowest possible number. Then only here I put the number 1. This carbon, this 1, then this is 2 and this is 3. Here which is the functional group here? OH. Here totally identify, here the first rule, identify the longest chain of carbon atoms to get the parent name. Here listen here, which is the longest chain? This is the longest chain. Here how many carbon here? 3 carbon. So here the root word is prop. The second rule, number of carbon atoms of the parent chain beginning at the closest end of the substituents or functional group. Here which is the functional group? Alcohol. So you have to number the carbon atom from this right side. So these are called as locant number. Substituent or functional group, these are called as locant number. If both functional group and substituent are present, then the priority will be given to the functional group. For example, here the first carbon, a functional group is there. Sometimes here the same carbon, another substituent is present, means you give priority to the functional group, that is OH. Rule 3, in the case of alkenes and alkynes, locate them. Locate means find the double bond or triple bond, use its locant number followed by a dash and a primary suffix. Primary suffix means single bond means ANE, double bond means ENE and triple bond means YNE. The carbon chain is numbered in such a way that the multiple bond means double bond or triple bond or single bond have the lowest possible locant number. For example, here a double bond is in the first carbon, a double bond is there means, so in this way, a left side only you have to number the carbon atom. So you have to number as 1, 2, 3. Now, rule 4. If the compound contains functional group, locate it and use its locant number followed by a dash and a secondary suffix. Here, the OH is the functional group. This is alcohol. The alcohol, you have to use the suffix. The secondary suffix is OL. Here, so locate the first carbon. So 3 carbon propane. The first carbon 1. First carbon, a functional group is attached. So how to name it here? Prop 1 whole. Can you understand? If the compound contains a functional group, OH is the functional group, and use its locant number followed by a dash and a secondary suffix. So here the 3 carbon atom means prop, the root word is prop, the number is 1, so prop 1 whole OL. Rule 5. When the primary and the secondary suffixes are joined, the terminal E of the primary suffix is removed. For example, 3-carbon means propane. You have to remove this last word E, remove E, and alcohol means you have to put OL. So, propanol. Rule 6. Identify the substituent. What do you mean by substituent? That is a methyl group or ethyl group, and use a number followed by a dash, a prefix to specify its location and identify. For example, a first carbon, a substituent, a methyl group, CH2 group is present means you have to number, you have to locate the number. 1 methyl, you have to mention like that. You have to identify the substituent methyl or ethyl or amino, chloro, bromo, anything. But you mention the number followed by a dash and a prefix. You have to number the prefix. The first carbon, a methyl group is present means 1 methyl you have to mention and to specify its location and identify. So these are the 6 rules to write the name of a IUPAC name of a compounds. Thank you, students.